And it looks like everything's working. Okay, so today we're going to finish up section 11.2 for our parametric equations. So let's say, for example, we wanted to determine the second derivative of the parametric curve represented by the equations say x is equal to negative 6t squared minus 3t minus 5, and y is equal to negative 6t to the third power minus 8t squared minus 2t plus 2. So in order to find the second derivative, first thing you have to do is find your first derivative. Oh, bless you. Okay, well, we know that the derivative of y with respect to x is equal to the derivative of y with respect to t divided by the derivative of x with respect to t. And let me line that up a little bit better than that. There we go. Okay, well, we know, kind of put that as a little side note, that if x is negative 6 times t squared minus 3t minus 5, then the derivative of x with respect to t is equal to, bring down our 2, we have negative 12 times t, and we have minus 3 times the derivative of t, which is just 1. So our dx dt is negative 12t minus 3. And our derivative of y with respect to t, we bring down the 3, that gives us negative 18t squared, minus, we bring down the 2, that's negative 16, so negative 16t. And the derivative of t is 1, so that's just minus 2. And the derivative of 2 is 0, so that would just disappear. So dy dt over dx dt is just negative 18t squared minus 16t minus 2 divided by your dx dt, which is negative 12t minus 3. Okay, so we're going to need that later, so we'll put a little marker around that one. Okay, we know that our second derivative of y with respect to x is just the derivative with respect to t of your dy dx divided by your dx dt. Okay, so that means your second derivative is equal to the derivative with respect to t of negative 18t squared minus 16t minus 2 divided by negative 12t minus 3. Divided by negative 12t minus 3. And all of that divided by your dx dt, which is negative 12t minus 3. Okay. Now for this part up here, we're going to have to use the quotient rule. Okay, so that means our second derivative, move this over a little bit so we have enough room, is equal to your denominator times the derivative of your numerator. So we have negative 12t minus 3 times the derivative of negative 18t squared minus 16t minus 2. So if we bring down the 2, it gives us negative 36t minus the derivative of negative 16t, which is just negative 16, minus the derivative of 2, which is 0, so that disappears. Okay, minus the numerator times the derivative of the denominator. So you have negative 18t squared minus 16t minus 2 times the derivative of your denominator, which is just negative 12. And all of that over your denominator squared. So it's negative 12t minus 3 squared. Move that over a little bit. And all of that is still divided by negative 12t minus 3. Because you can't forget about that denominator down there. Okay, but we can simplify this by just combining this negative 12t minus 3 with this denominator. And all we have to do is multiply the numerator and denominator by 1 over negative 12t minus 3. If you multiply these two, they just cancel each other out and give you 1. Okay, but we might as well go ahead and simplify our numerators. So this first term, we're just going to use the FOIL method, and this second term, we're just going to distribute that negative 12 and the negative for the minus. Okay, so we have negative 12t times negative 36t, so that gives us 432t squared. Our outer is negative 12t times negative 16, which is positive 192t. Our inner is negative 3 times negative 36t, which is positive 108t. And our last is negative 3 times negative 16, which is positive 48. And let me move this over. Why am I still starting an inch and a half out, knowing I'm going to run out of room? Don't want it that close. So we have 432t squared. Let me move that over a little bit. Plus 192t. Figured I'll catch it now before I get to the end and run out of room. Plus 108t. Plus 48. There we go. Minus, and we distribute that negative 12. Negative 12 times negative 18t is 216t squared. Negative 12 times negative 16 gives us positive 192t. And negative 12 times negative 2 is positive 24. And all of that divided by, and if we combine these two, negative 12t minus 3 squared times negative 12t minus 3, that's just negative 12t minus 3 to the third power. Whoops, you realize that was crooked. Okay, so we have just enough room to simplify it. Okay, so if we have 432t squared, and if we distribute that negative, that'll be minus 216t squared. 432 minus 216 is just 216 t squared. Okay, so you just have 192t. We distribute this negative, that'll make this negative 192t. So these two actually cancel each other out. Okay, so that just leaves plus 108t. Then we have 48 minus 24. That's just positive 24 divided by negative 12t minus 3 to the third power. And we'll finish it up on the next page. All right. And let me just write down where I left off. So we have 216t squared plus 108 t plus 24 divided by negative 12t minus 3 to the third power. Okay, so this one, you could leave it like this and Newton probably will accept it, but it's not in its simplest form, so you're kind of taking a chance. Okay, so like I said, you could put this in. I would definitely try to put that in first. But if they don't accept it because it's not in the simplest form, then all we have to do is expand our denominator and simplify. Okay, so we have 216t squared plus 108t plus 24 divided by, so we take negative 12t minus 3 times negative 12t minus 3 times negative 12t minus 3, we have negative 1,728t to the third power minus 1,296t squared minus 324t minus 27. Okay, we can actually factor a 3 out of the numerator and denominator. Excuse me. Okay, so up here we'll factor out a 3. That's 3 times 72t squared plus 36t plus 8 divided by, and just to get this first term positive, we'll factor out a negative 3. So we have negative 3. That's 576t to the third power plus 432t squared plus 108t plus 9, where of course the 3's cancel each other out. Bring that down, there we go. Which just leaves a final answer of negative 72t squared plus 36t plus 8 divided by 576t to the third power plus 432t squared plus 108t plus 9. But before going through all that, I would definitely just try that to see if it works. All right, so are there any questions on that one? Excuse me. All right. Oh, I'm sorry, anyone still writing? Forgot to ask. All right. Okay, so what if we wanted to determine the second derivative of the parametric curve represented by x of t is equal to 4 times sine of 2t, and y of t is equal to negative 6 times cosine of 2t. So the first step that you want to do is find your dy dx. Okay, so we know our dy dx is equal to your derivative of y with respect to t divided by your derivative of x with respect to t. Okay, well, we know that our y is equal to -6 times cosine of 2t. So the derivative of cosine is negative sine. So we know that the derivative of cosine of 2t is negative sine of 2t times 2, because times the derivative of 2t. Okay, so that will end up being positive 12 times sine of 2t. Divided by the derivative of sine is cosine. So we know that the derivative of sine of 2t is cosine of 2t times the derivative of what's inside. So that's times 2. So that 2 times 4, that'll give us 8 times cosine of 2t. Or we can simplify it and just make that 3 times sine of 2t divided by 2 times cosine of 2t. Okay, so we have our dy dx. Okay, and we know that our second derivative of y with respect to x is equal to the derivative with respect to t of your dy dx divided by your dx dt. Well, we know that our dy dx is 3 times sine t divided by 2 times cosine of 2t. So our second derivative is just equal to the derivative, make that d a little clearer, the derivative with respect to t of your dy dx, which is 3 times sine of 2t divided by 2 times cosine of 2t. And that divided by your dx dt, which is 8 times cosine of 2t. Because remember, we have to look at the original value of dx dt before we simplify it. Okay, so once again here, we know to find this derivative, we're going to have to use the quotient rule. Okay, so we have our denominator, 2 times cosine of 2t, times the derivative of our numerator. The derivative of sine is cosine. So if we take the derivative of sine of 2t, that's cosine of 2t times 2, the derivative of that 2t. So multiply that 2 times 3, and we get 6. So you have 6 times cosine of 2t minus the numerator, so 3 times sine of 2t, times the derivative of our denominator. So the derivative of cosine is negative sine. So that becomes 2 times negative sine of 2t times 2, which is the derivative of that 2t. So that gives us negative 4 times sine of 2t. All divided by your denominator squared, which is 2 times cosine of 2t squared. And all of that is divided by 8 times cosine of 2t. Okay, so if we simplify this, we can go ahead and multiply 6 and 2, and we can multiply 3 and negative 4. So we end up with 12, and if we cosine and cosine, that's cosine squared. So we have cosine squared of 2t minus, well, this minus negatives becomes plus, so we can go ahead and just make that plus. 3 times 4 is 12, so we have 12 sine of 2t times sine of 2t is sine squared of 2t. Divided by, and we can combine these two denominators like we did before. So that's just 2 times cosine of 2t squared times 8 times cosine of 2t. Okay, well, if we simplified our denominator a little bit more, we'd have 12 times cosine squared of 2t plus 12 times sine squared of 2t. And that 2 times cosine of 2t squared, well, that'll give us 2 squared. So that's 4 times cosine squared of 2t. Times 8 times cosine of 2t. Actually, everything here is multiplied, so we don't even need the dots, but we'll put the little multiplication dots there anyway. Okay, so we simplify that denominator a little bit more. We have 12. Actually, we can factor 12 out of here. And that'll just leave us with cosine squared plus sine squared. divided by, we have 32. We multiply the 8 and the 4. So we have 32. And cosine squared of 2t times cosine of 2t is cosine of 2t to the third power. I thought I'd be able to finish it on this page, but I'm not going to try and squeeze it all on that little spot. All right, let me move that up just a little bit and rewrite where we left off. So 12 times cosine squared of 2t plus sine squared of 2t divided by 32 times cosine cubed of 2t. Well, we know that sine squared plus cosine squared, had a feeling I'd run out of room. You need to make wider paper, or I'll just write smaller. So cosine squared of 2t plus sine squared of 2t is equal to 1. So we could rewrite this as 12 times 1, or just 12. I just wrote the 1 just because, divided by 32 times cosine cubed of 2t. Okay. Well, we can simplify that. We could have actually done that a while ago, but we'll do it now. 6 goes into 12 twice. Not 6. 4 goes into 12 3 times, because 6 doesn't go into 32, and 4 goes into 32 8 times. Okay. So it leaves us with 3 over 8 times 1 over cosine cubed of 2t. Uh-oh, sorry about that. Didn't realize it was so low on the page. Okay. And again, Newton might take this answer, or you can put it as 3 divided by 8 times cosine cubed of 2t. Or it might take it as 3 over 8, and 1 over cosine cubed is secant cubed, so that could be secant cubed of 2t. But again, they should take this if you put it in this way, but it's possible they may want it simplified even more. Uh-oh. Move that out the way. All right, any questions on that one? All right. Okay, so what if we wanted to determine the concavity of the parametric curve by the parametric equations x of t is equal to 5t squared plus 5t minus 9, and y of t is equal to negative 5t to the third power plus 8t squared minus t minus 9. We want to know the concavity when t is equal to 1. Okay. So for this one, you want to remember that when the second derivative is positive at some point c, we know it's concave up. When the second derivative is negative at that point, we know it's concave down. And we know that when the second derivative equals 0, the test failed and we have to use the first derivative test, which we don't want to do that. There's more work. We want to use first derivative test. Oops, forgot to close that up. So just a little reminder note of the second derivative test. Okay, so just like before, first thing we're going to do is find our dy dx. Your derivative of y with respect to x. We know that's equal to the derivative of y with respect to t divided by the derivative of x with respect to t. Okay, so we see that y is equal to negative 15t to the third power plus 8t squared minus t minus 9. So to find our derivative of y with respect to t, we bring down the 3, so that gives us negative 15t squared plus, we bring down the 2, so that gives us plus 16t minus the derivative of t, which is just minus 1, minus the derivative of 9. Well, the derivative of a constant is 0, so that just disappears, divided by the derivative of x with respect to t. Excuse me. Okay, so we know that x is 5t squared plus 5t minus 9. So if we bring down the 2, that would give us 10t plus the derivative of 5t is just 5 minus the derivative of a constant, which is 0, so that just disappears. Okay, so we know that the second derivative is just the derivative with respect to t, your dy dx, divided by your dx dt. Well, that's just the derivative with respect to t of negative 15t squared plus 16t minus 1 divided by 10t plus 5. Oops, there we go. And all of that divided by your dx dt, which is 10t plus 5. Okay, so once again, we know that for this derivative, we're going to have to use the quotient rule. Or you could use the product rule if you rewrote this as the numerator and you just made it times 10t plus 5 to the negative 1 power. Then you could just use the product rule, but I don't do that a lot because it can get confusing and make mistakes. So sometimes I just stick to the quotient rule. Okay, so that's going to equal, you have your denominator, which is, I move this all the way. Eventually I'm going to learn my lesson. Stop starting so far over. Okay, so we have our denominator, 10t plus 5, times the derivative of the numerator. So if we bring down the 2, that's negative 30t plus 16. And derivative of negative 1 is 0, so that disappears. Minus the numerator, which is negative 15t squared plus 16t minus 1, times the derivative of your denominator, which is just 10, all over the denominator squared. So 10t plus 5 squared. Okay, and that derivative is divided by that 10t plus 5 that was already there. 10t plus 5. There we go. Okay, so to multiply these two, we can just go ahead and do the FOIL method. And for this one, we can just distribute that 10. Move this over a little bit. Okay, so our first will give us negative 300t squared outer will give us 16 times 10t, which is 160t. Our inner, 5 times 30, gives us negative 150, or negative 30. So negative 150t. And our last is 5 times 16, which would give us 80. Actually, I might as well do it all together instead of adding unnecessary steps. Okay, so 10 times negative 15 is negative 150. But if we distribute this negative, that makes it positive 150t squared. Sixteen times 10 is 160. That makes that negative 160t. 10 times negative 1 is negative 10. Distribute that, it becomes positive 10. Divided by, we have 10t plus 5 squared. Divided by the 10t plus 5. We can combine these two denominators like we did before. Make it 10t plus 5 to the third power. And we'll finish on the next page. I'll leave that up for a little bit. Well, actually, we can look before rewriting it and see that this 160t and negative 160t cancel each other out. Okay, anyone still writing? All right. Right up here for right now. Okay, so if we combine our negative 300t squared plus 150t squared, we'd end up with negative 150t squared. Okay. Now if we combine negative 150t, well, these two already canceled each other out, so it's still negative 150t. And we combine the 80 plus 10, that gives us 90, divided by that 10t plus 5 to the third power. Okay. We can kind of see here that 90, 150, and 150, they have a common factor. So we're going to expand this to see if there's a common factor in those terms. And here's a way to do it this way. You can factor out the 5 and then just 5 to the third power and then just split it apart. But I'll do it the other way just because it's there. That's the only reason. All right. So if we expand our denominator, it gives us negative 150t squared minus 150t plus 90 divided by, we get 10t plus 5 times 10t plus 5 times 10t plus 5. That'll give us 1000t to the third power plus 1500t squared plus 750t plus 125. Excuse me. Okay, so on the numerator and denominator, we could factor out a 5, but just to have this first term positive, I'll factor out a negative 5 from the numerator and a positive 5 from the denominator. Like I said, for no other reason than to have that first term positive. Okay, so if we factor a negative 5 from our numerator, that will leave us with 30t squared plus 30t minus 18. And if we factored out a positive 5 in our denominator, that will leave us with 200t to the third power plus 300t squared plus 150t, make that a little bit longer, plus 25. Where, of course, the 5s cancel each other out. Okay, so that leaves us with, actually, if it wasn't for that 18, we probably could have simplified it a little bit more. That our second derivative with respect to x is equal to, got my negative there, negative 30t squared plus 30t minus 18 divided by 200t to the third power plus 300t squared plus 150t plus 25. Okay, now we want to know whether it's concave up or concave down at t equals 1. So the second derivative of y with respect to x as t is equal to 1 is equal to negative 30 times 1 squared plus 30 times 1 minus 18 divided by 200 times 1 plus 300, we'll say 1 to the third power, even though it's still 1, but jumping ahead. So 300 times 1 squared plus 150 times 1 plus 25. Okay, so that gives us negative 30 plus, oh, did I say? Yep, I did. 3 times 1, it should be 30 times 1. Okay, so 30 plus 30 minus 18 is 42. Divided by 200 plus 300 plus 500 plus 25 is 675. Okay, so we know that this derivative is negative 42, or the second derivative is negative 42 over 675, which is less than 0. Okay, so the final answer really didn't matter much. We just needed to know whether it was positive or negative. Oh, bless you. So since it's less than 0, we know that the curve is concave down. So since the second derivative is less than 0 at t equals 1, we know the parametric curve is concave down at t equals 1. Okay, so they could have a question where they could ask for the concavity, or they could ask anything at all, where you'd have to just remember that rules for the second derivative. Okay, so we know that if it's the inflection point, we'd have to find out where the second derivative is equal to 0. So it all depends on what question they're asking. All right. Any questions on that one? All right. Anyone still writing? Okay. What if we wanted to find the area under a parametric curve? Okay, well, that area is just equal to the integral from a to b of y of t times x prime of t with respect to t. And the proof was a little lengthy and kind of unnecessary, so we're not going to even go over the proof on this one. I'm pretty sure it's Googleable, if that's a word. So let's say, for example, if we wanted to find the area under the parametric curve that is defined by x, you can say x or x of t is equal to 6t minus 3, and y of t is equal to 7t plus 8. on the interval from 3 to 5. Okay, so we know that our x of t is equal to 6t minus 3. And the derivative of our x with respect to t is just 6. So x prime of t is equal to 6. And make that prime a little bigger. There we go. And we know that y of t is equal to 7t plus 8. And clean up that t. There we go. Okay. So to find the area, you really only need these two. So since the area is the interval from a to b of y of t times x prime of t with respect to t, well, since the interval is from 3 to 5, I'll make a little side note here. 3 is less than or equal to t is less than or equal to 5. And this 3 is our a, and that 5 is our b, since that's our interval. So that gives us the integral from 3 to 5 of y prime of t, which is 7t plus 8. 7t plus 8 times x prime of t, which is 6, with respect to t. And clean up that equal sign a little bit. There we go. So if you wanted to, you could factor out the 6 or you could distribute the 6. Just personal preference on that one. Okay, so that's the integral from 3 to 5 of 6 times 7t is 42t, plus 6 times 8 is 48. With respect to t. Okay, so we just need to go ahead and take the integral of both terms. So our first term is 42 times the integral of t, which is t squared over 2, plus the integral of 48 is 48t, and that's from t equals 3 to 5. Well, we can go ahead and simplify this one. So 42 divided by 2 is 21. So we have 21t squared plus 48t over the interval from 3 to 5. Okay, so now all we have to do is apply the fundamental theorem, plug in our upper limit. Okay, move it over, make sure I have enough room. So that's 21 times 5 squared plus 48 times 5 minus, now we plug in our lower limit, 21 times 3 squared plus 48 times 3. Okay. So if we plug that into our calculator, we end up with 765 minus 333, which gives us 432. All right, so any questions on that one? All right. So what if we look at the arc length of a parametric curve? Uh-oh. So that arc length that we will call L is equal to the integral from A to B times the square root of x prime of t squared plus y prime of t squared with respect to t. And again, the proof is lengthy and not really necessary here, so kind of bypass the proof. Okay, so let's say, for example, if we wanted to find the arc length of the curve defined by the parametric equations, x of t is equal to 8 times the square root of 5t, and y of t is equal to the square root of 7t. Okay, and we know that's for the interval from 1 to 2. know the interval from 1 to 2, put that there before we start. We know that's our A and that's our B. Okay, so our arc length is equal to the integral from 1 to 2 of the square root of x prime of t squared. Now on this side, let's go ahead and get our x prime of t. Okay, so if our x of t is equal to 8 times, and instead of the square root of 5t, we'll have 5t to the 1/2 power. So if we bring down the exponent, that gives us 8 times 1/2 times 5t to the power of 1/2 minus 1, which gives us 5t to the negative 1/2 power. Okay, times the derivative of what's inside, which is 5. Oops. Okay, so 8 times 1/2 just gives us 4. And 4 times 5 gives us 40. We have 40 over the square root of 5t. Oops. Oh, got to mark that this is x prime of t. Here we go. And our y of t is equal to the square root of 7t, which means that y prime of t, I actually rewrite that to the 1/2 power, make it a little easier on us. Okay, so we have 7t to the 1/2 power. So the derivative of that, bring down the 1/2, times 7t to the power of 1/2 minus 1, which is negative 1/2, times the derivative of what's inside, which is 7. So our y prime of t is equal to 7 over 2 times the square root of 7t. Yes?
For the x prime of t, you forgot to bring down the 1/2.
Oh, nope, I did. We brought down the 1/2, and then we subtracted the 1, which made it negative 1/2. But when we multiplied these two together, we got, I see what you're saying. I did skip over that one. Yeah, but I did bring it down, just forgot to multiply and make it 4.
You forgot to bring it down.
Yeah.
Down multiplication.
Yeah, so I did bring it down, but I did forget to multiply. Thank you. So we have 4 times 5, which is 20. There we go. Okay, so our x prime of t squared will just become 20 over 5 square root of t squared. plus our y prime of t squared is just 7 over 2 times square root of 7t squared. With respect to t. Okay. So before we square it, we can simplify it a little bit because this 20 divided by 5 is just 4. So the smaller the numbers we work with, the easier it is for us. So that gives us 4 over square root of t squared. Oops, square root of 5t. Why did I put the 5 on the outside? Square root of 5t and square root of 5t. There we go. Plus 7. I can't really simplify that one, so we'll just leave it as 7 over 2 divided by square root of 7t squared. And clean that up a little bit better than that. There we go. With respect to t. I mean, we could have simplified it. Change that 7 to square root of 7 times square root of 7 and cancel out with that square root of 7. But it's not really necessary. Okay. So if we do go ahead and simplify it, that gives us the integral from 1 to 2 of the square root of 16, since 4 squared is 16, divided by the square root of 5t squared is just 5t. Okay, plus, we get 7 squared, we'll get 49, over 2 squared, which is 4, times the square root of 7t squared is just 7t. With respect to t. Okay, so we can actually simplify this because this 49 divides with this 7 here. So we can rewrite this as the integral from 1 to 2 of the square root of 16 over 5t. Oh, that's right, I did realize that was an error, but I didn't correct it after that because I had the 5 on the outside. So really, that should still be 20 squared. So that wouldn't have been 4. So did catch that. After that one, I just kind of kept going without correcting for that one. So after correcting that one, we have 20 squared divided by square root of 5t squared. So 20 squared is 400. I'll just write 20 here. So 20 squared is 400. I think 20 squared is 400. Let me double check. It should be 400. Yep. Okay, so we have 400 divided by 5t plus 7 divided by 4t. And we can simplify that one. It's 400 divided by 5, which is 80. Trying to think if that would be the best way. So 400 divided by 5, we just make that 80. So instead of rewriting all of that, we're just going ahead and make that 80 right here. No point in rewriting the whole group of steps just for that one correction. Okay, so the only thing left to do is add those two together, which means we can just multiply this by 4 over 4 to give us our like denominators. So we have the integral from 1 to 2 of the square root, and we'll just go ahead and simplify this here. So we have 80 times 4, which is 320 plus 7, the square root of 327 divided by 4t with respect to t. Okay, now we want to be able to integrate this, so we have to get rid of that square root. So we have the integral from 1 to 2. We have the square root of 27 over 4t. We can rewrite that as the square root of 327 divided by the square root of 4, which is 2, times the square root of t. Now that square root of 4t, we could easily make that square root of 4 times square root of t, which is just 2 times the square root of t. But with our square root of t in the denominator, we can just rewrite that as t to the negative 1/2 power with respect to t. Oops, ran out of pencil lead. There we go. And we'll finish this up on the next page. Okay, so we can finally factor this constant out to the front, which we will do on the next page. And there we go. That means our length is equal to the integral from 1 to 2. We have to actually factor that out instead of rewriting the whole thing. So it's equal to the square root of 327 over 2 times the integral from 1 to 2 of t to the negative 1/2 power with respect to t. Okay, so now we can integrate after all of that. Oops, straighten that up. So this integral would just be the square root of 327 divided by 2 times the integral of t to the negative 1/2 power, which is t to the negative 1/2 plus 1, which is 1/2, divided by 1/2. Okay, and normally I'd multiply this by 2/2 to get rid of the 1/2 in the denominator, but because this 2 is already there, we multiply those two, we do get 1. So our length is equal to the square root 300, forgot from 1 to 2, the square root of 327 times t to the 1/2 power. I'll just go ahead and write that as square root of t, from t equals 1 to 2. Okay, so now we can go ahead and apply the fundamental theorem. So the square root of 327, plug in our upper limit, that gives us the square root of 2, minus, plug in our lower limit, give us the square root of 1, or you can just put 1, but I'll put square root of 1 just because. Okay, so we left it as the square root of 327 times the square root of 2 minus 1. That would just be our exact answer, if they ask for the exact answer. Or you could distribute the square root of 327, but you don't have to. Okay. Now, they wanted a decimal approximation. Of course, just plug that into your calculator. And you get 7.49028, or 7.49, rounded to 2 decimal places. All right, so any questions on that one? All right, anyone still writing? All right. Now we're going to look at the surface area of a parametric curve. Okay, so the surface area is usually denoted by an S, and that's equal to 2 pi times the integral from a to b of your function y of t times the square root of x prime of t squared plus y prime of t squared with respect to t. Okay, so let's say, for example, if we wanted to find the surface area of a sphere of radius 9, centered at the origin. Which is defined by the parametric equation or equations. X of t is equal to -9 times cosine of 2t. Y of t is equal to -9 times sine of 2t. But we know t is between -pi/2 and 0. Excuse me. Excuse me. Okay, so we know that since our x of t is equal to -9 times cosine of 2t, then our x prime of t, the derivative of cosine is negative sine, so that's negative sine of t, well, negative sine of 2t times the derivative of 2t, which is 2. So the negatives cancel out, and that 2 times 9 gives us 18 times sine of 2t. And that y of t is equal to -9 times sine of 2t. Which means that y prime of t is equal to the derivative of sine is cosine. So that derivative would be cosine of 2t times the derivative of what's in there, which is 2. So 2 times -9 is -18 times cosine of 2t. Okay, so we know that the surface area is equal to 2 pi times the interval from a to b. So this would be 2 pi times the interval from -pi/2 to 0. Times y of t. So that y of t is -9 sine of 2t times the square root of x prime of t squared. So that's 18 times sine of 2t squared and that whole thing squared, plus your y prime of t, which is negative 18 times cosine of 2t squared. And that's with respect to t. Okay, so we have to tweak this a little bit before we can actually integrate it. So we have 2 pi times the integral of negative pi over 2 to 0 of negative 9 sine of 2t times the square root. This will actually give us 18 squared. Well, you could leave it as 18 squared, or you could just make it 324. Up to you. But I'll just make it 324 times sine squared of 2t. Actually, with this one, I'll just go ahead and do the steps. Won't skip that one. Plus negative 18 squared. Negative times negative is positive. So that's, again, positive 324 times cosine of 2t squared, which is cosine of 2t squared with respect to t. Okay, so this factor right here that radicand, we can actually factor out a 324. So this will become the square root of 324 times sine squared of 2t plus cosine squared of 2t. And instead of writing the entire steps, we'll just put that little substitution there. Which means we can split those two apart. So 2 pi times the integral from negative pi over 2 to 0. And we could have combined those two anytime we wanted to, but I'll just keep on bringing it down. Negative 9 times sine of 2t. And that's square root of 324 times sine squared plus cosine squared. We can break that up and just make that the square root of 324 times the square root of sine squared plus cosine squared. With respect to t. Now, the reason I waited was only because I figured I would get all of those factors and bring them out all at once. Okay, so this one, that gives us the square root of 324 times 2 pi times negative 9 times the integral of negative pi over 2 to 0 of sine of 2t, and this square root of sine squared plus cosine squared, well, sine squared plus cosine squared is equal to 1. So the square root of 1 means that this entire thing just turns into 1. So that just leaves us with the integral of sine of 2t with respect to t. Okay, so we have our square root of 324. Actually, the square root of 324 is just 18. So we can just stop writing that and just put that 18. And I'll leave this factored only because it's going to simplify a little bit. So I'll leave it as 2 pi times negative 9. I mean, you could work it all out and still simplify it at the end, but it's a little easier to do it here. Okay, times the integral from negative pi over 2. Actually, we can go ahead and integrate that. No point in rewriting it all over again. So if we use u substitution and integrate sine of 2t, then that will give us negative cosine of 2t divided by 2. And that's from negative pi over 2 to 0. Okay. So again, the only reason I didn't combine these two is because I knew that this 2 and this 2 would cancel out. But normally I probably would have combined them in the end, just simplify that product. Okay, so we have 18 times negative 9, but these two negatives, we can just go ahead and cancel those out because they just multiply to give us positive 1. That gives us 18 times positive 9, which gives us positive 162. And we can't forget that little pi that's hiding in there. And so that gives us 162 pi times cosine of 2t from t equals negative pi over 2 to 0. Where we can go ahead now and apply the fundamental theorem. So we plug in our upper bound. So we have 162 pi times cosine of 2 times 0, which is just 0, but I'll just write out actually 2 times 0, minus cosine of 2 times negative pi over 2, which is just negative pi. I'll just say 2 times, I'll actually write it out, negative pi over 2. That gives us 162 pi times cosine of 0, which is just 1, minus cosine of negative pi, because these 2's will cancel out, which is negative 1, so minus negative 1. And make that 1 look just like the other one. There we go. Okay, so that just gives us 162 pi times 2. which is 324 pi. Uh-oh. Which is your exact answer if they want the exact answer. But plug that into your calculator, and you should get approximately 1017.88. Just round it to the nearest hundredths. Okay, so most of those formulas, you're just plugging it in. The hardest part is kind of manipulating them to where you can actually integrate them. But once you're able to actually integrate them, it's not horrible if you remember all the little steps. All right, so any questions on this one? All right. All right, anyone still writing? Nope, okay. Excuse me. Okay, so now we're going to start on 11.3. Which covers polar coordinates. Okay. So for polar coordinate, let's say if we have on our X and Y axis, we have some point here, the ordered pair XY to represent that point. Okay, so let's say instead of going the route of, well, when X is equal to this and Y is equal to this, we end up at that point. Let's say if we start at the origin and we go out and we have a ray or a line of radius R. Some radius value we'll call R. Now, if we get that line and swing it up now to where the tip of this radius is now right at that same point. But that line, we knew we had to swing it up, move that R and put it up on this one. Some theta degrees or theta radians, depending on which form it's in. So now we have that point that was represented as the ordered pair XY is now represented by the radius and theta. Because you can get to the very same point using the radius, correct radius, and correct angle. So all we did is we turned an XY Cartesian coordinate Cartesian or rectangular coordinate, depending on who you ask, into a polar coordinate. Okay, so if we take that one little angle there and we kind of redraw it without the X and Y axis and all of that stuff there. Actually, we don't really need the arrows. We can just put the points at the end. Okay, so we know that the distance between your point xy or r theta, that's your radius. Okay, the point where the two line segments meet, that's your origin. And the line where you started, that's your polar axis. Now, one of the big differences between the Cartesian coordinate and the polar coordinate is that when you have, let's say, the point 3, 5, x is 3, y is 5, it's just x is 3, y is 5. That's what the point is represented by. But with the Cartesian coordinate, that point has an infinite number of coordinates. Literally an infinite number. So r theta, you can rewrite that as the radius and theta plus 2n pi. Because let's say if we get to that point, we go 2 pi around, we end up right back at the same point. We go 2 pi around twice, we end up back at the same point. We can go 2 pi an infinite number of times, and we will end up right back at that exact same point. So if we're just going in a circle an infinite number of times, then we will end up at that exact point an infinite number of times. Or we can go in the clockwise direction and get the exact same thing. The radius and theta minus 2n pi. Okay, so one visual example just to kind of show you why that would be true is, let's say if we have some polar coordinate let's do our x and y axis. Well, the radius is 3 and the angle is negative pi over 6. Oops. Well, we can get that point, that polar coordinate 3. Let me move that over a little bit because I can see myself running out of room. Actually, let me put it underneath it just to make sure I don't run out of room. So 3 negative pi over 6 we can rewrite that as 3 and negative pi over 6 plus 2 pi. Pretty much just making n equal 1. So we could rewrite that as the radius of 3 and that negative pi over 6, that 2 pi, we can make that 12 pi over 6. So 3, the coordinate 3 negative pi over 6, we can rewrite that as 3 11 pi over 6. And it will put us right back at the exact same spot. The only difference is we're going out a radius of 3 and we're going 11 pi over 6 in the other direction, in the counterclockwise direction. And we can do that if we change it to 4 pi, 6 pi, 8 pi, 12 pi, literally any even number times pi. All right, anyone still writing? All right. Okay. So now we're going to look at coordinate conversion. We're going to convert a polar coordinate to a Cartesian coordinate and a Cartesian coordinate to a polar coordinate. Okay, so what if we have our x and y axis? Where we have our radius that we will call r. And this point here is some ordered pair x, y, so that's our rectangular coordinate. And of course, this is a right triangle. Okay. So this is our angle theta. Of course, the distance, the vertical distance to this point is some value we will call y. And the horizontal distance to that point is a value that we will call x. Okay, so if we look at sine of theta, well, we know the sine is opposite over hypotenuse. Well, from this angle, the opposite is y, and the hypotenuse is the radius. If we look at cosine, we know that's adjacent over hypotenuse. Well, the adjacent is x, and the hypotenuse is r. And tangent is opposite over adjacent. So tangent would just be the opposite, which is y, over the adjacent, which is x. Okay. So that means if we multiply both sides by the radius, then y is equal to r times sine of theta. Same thing for cosine. If we multiply both sides by the radius, we have x is equal to r times sine of theta. Okay. And we also know that for this one, x squared plus y squared would equal 1, or x squared plus y squared is equal to r squared, because we didn't specify that this was a unit, or the radius was 1, so that's just the radius squared. Okay, so these are the conversion formulas that you will use. Okay, so if you are given r and theta, you could find your x and y coordinates. If you're given x and y, you could find your polar coordinates. Yes.
For the x equals, you accidentally dropped the cosine.
Which one?
The x.
Oh, yeah, you're right. Thank you for catching that one. So x be r cosine of theta. Okay, so let's say, for example, we wanted to convert the polar coordinates to rectangular. And remember, they might say convert them to rectangular or Cartesian coordinates. They're literally the exact same thing. So let's say for problem A, you have r theta, the radius is 2, and the angle is pi. And for B, our r theta is equal to square root of 3 and pi over 6. Okay, so let's look at A. Well, we know for A, we have the polar coordinate 2 pi, which means that your radius equals 2 and your angle is equal to pi radians. Make that pi a little bit neater than that. Okay, well, we know that x is equal to r times cosine of theta. So we just use radius and theta to solve for x, which means that x is equal to 2 times cosine of pi. We know that cosine of pi is -1. So we know that the x component is just -2, well, 2 times -1, which is -2. And we know that y is equal to r times sine of theta. Which means that y is equal to 2 times sine of pi. Well, we know that sine of pi is just equal to 0. So we know that y is just equal to 0. So we know that, I'm about to say r theta. The point 2 pi is the same as negative 2, 0. And if you think about it visually, to do a really quick visual aid here, make that a little bit longer. Okay. We take the point negative 2, 0. Let's say this is our 2. So this is the point negative 2, 0. Okay, so what if we take our line and we have a line with a radius of 2? So if it has a radius of 2 and we swing it around pi degrees, it just swings around and ends up right there. So we end up with the exact same spot with 2 different coordinates. Well, same coordinates, but 2 different notations for the coordinates. One in polar form and one in Cartesian form. All right. So any questions on that one? That kind of sort of somewhat makes sense? Okay. Now let's look at B, and we do the exact same thing. We have the polar coordinates, square root of 3 and pi over 6. So we know that's our radius, and that's our theta. Okay. So again, we know that x is equal to r times cosine of theta. Which means in this case, x will equal square root of 3 times cosine pi over 6. Okay. Well, cosine of pi over 6, we know that that is square root of 3 over 2. And make that square root of 3 a little clearer. Square root of 3 over 2. So square root of 3 times square root of 3 is just 3. That means that x is equal to 3 over 2. And y is equal to r times sine of theta. Actually, let me bring that down so it won't run into that one. Which means that y will equal square root of 3 times sine of pi over 6. Well, sine of pi over 6 is just 1/2. I forgot my equal sign there. Equals 1/2. So that means that y is just equal to square root of 3 over 2. which means our polar coordinates, square root of 3 pi over 6, is in the exact same place as the coordinates 3 over 2, square root of 3 over 2. All right, so any questions on that one? Okay, so that's how you convert polar to rectangular. But what if we wanted to convert rectangular to polar? Oh, anyone still writing? All right. A few more sheets of paper just to make sure we don't run out. Getting a little bit low. So now we're going to look at rectangular to polar conversions. Okay. So in this case, we're given our x and y and need to find our r and theta. So we're going to start off just what we did before. X is equal to r times cosine of theta. Y equals r times sine of theta. And tangent of theta is equal to y over x. And we have our r squared is equal to x squared plus y squared using the Pythagorean theorem. Okay. Now we know if we apply tangent inverse to both sides, that theta will equal the tangent inverse of y over x. So we definitely use that one to find our theta. And if we square root both sides, we have the radius will equal plus or minus, but we know it's not going to be a minus length, so we know it's going to be plus the square root of x squared plus y squared. So we can find our radius. Okay, so let's say, for example, if for the second quadrant, convert the rectangular coordinates -1, 1 to a polar coordinate. Okay. Now, the fact that it's in the second quadrant is actually really important, and at the very end, I'll show you why. But for right now, let's just solve this one. So visually, we know that on our x and y axis, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So -1, 1 is somewhere in quadrant 2. Okay, so we know that theta is equal to tangent inverse of y over x. Well, we know that x is -1 and y is +1, just from our coordinates. So that's equal to tangent inverse of y, which is 1 over -1. Which is tangent inverse of -1. Oops. So we know that our theta is equal to tangent inverse of 1. Okay. Or if you wanted to, you could apply tangent to both sides and rewrite it as tangent of theta is equal to -1. -1. Let me clean that up a little bit. Make sure it's a little neater than that. There we go. So tangent of theta is equal to -1. And that's true when theta is equal to 3 pi over 4. Remember that theta has to be in the domain of your inverse tangent function. Okay. Now to find our radius, we know that our radius is equal to the square root of x squared plus y squared. Okay. So again, we know that x is -1 and y is 1. Let me make a little side note of that. -1, 1, your x and your y. Okay, so if we plug those in, the radius is just the square root of -1 squared plus 1 squared, which gives you the square root of 1 plus 1, which is just the square root of 2. So our radius is equal to the square root of 2. Okay, so that means the point -1, 1 converts to your r theta, which is square root of 2, 3 pi over 4. Okay, or, and this is just in case Newton decides to just be a jerk about it, the actual answer, even though this is a point, is the fact that you have to point out that it converts to the point square root of 2 and 3 pi over 4 plus 2n pi. That's technically the right answer. This answer is just one of an infinite number of answers. Like I said, if they're really just feeling like jerks, they could want the answer like this. So even though this is correct, you might have to put it like this to be absolutely 100% correct, where there's literally no argument about that being right. All right, so any questions on that one? Okay, so let's take a quick look back up See, why was that second quadrant so important? Because without the second quadrant, we could easily just say tangent of -1 is in the fourth quadrant. We can make x equal 1 and y equal -1, and you'll still end up with tangent of -1. Ooh. Okay, so we know just to kind of point out the differences between the two. Bless you. Let's look at quadrant 2. We have the point -1, 1. And look at the point in quadrant 4. We have the point 1, -1. Okay, well, we already saw here that if it's -1, 1, let's just work it out. Tangent inverse y over x equals theta. That gives you tangent inverse of -1 equals theta, where theta is equal to 3 pi over 4, but that's in quadrant 2. Uh-oh. Okay, that's the one we just did. But here, in quadrant 4, we had tangent inverse of y over x equals theta. If we had the point 1, -1, we'd still get tangent inverse of -1. And make that theta a little neater than that. Letting my messy handwriting take over. There we go. But in this case, it's -1 over 1, and up here it's 1 over -1. So still will give you -1. But in this coordinate, theta would equal 7 pi over 4 in quadrant 4. But why do I keep wanting to turn my q into a theta? There we go. So there are two possible answers for tangent inverse of -1. That's why they had to say the coordinates, even though they gave you the point -1, 1 up here. Sometimes letting you know which quadrant is a nice little reminder not to use the wrong quadrant. So it's a really helpful hint when they tell you the quadrant. All right, so any questions on that one? All right. Okay, now this one is actually one of the little tricky ones you might run into. So I figured I'd show you how to avoid being stuck on a problem like this. So what if we wanted to convert the point 0,2 to a polar coordinate? Okay, so with this one, if you notice, if we take, separate that comma a little bit, the point 0,2, of course, this is our x, and this is our y. if you take tangent of theta is equal to y over x, then that will give you tangent of theta is equal to 2 over 0, which is undefined. Okay. So with problems like this, whenever your x is 0, it's just easier to plot the graph or plot the point. Yep, plot the point. On a graph. So if we do that, and bring that down a little bit so it's not running into my little note there. Okay, so the point 0.02 would be about right there. This is our 2. So let's say this is the point 0.02. Well, we know that this y-axis is pi over 2, pi, 3 pi over 2, and 1 full circle is 2 pi. So the point 0.02, you're actually on the y-axis, the positive y-axis, which means that your theta is equal to pi over 2. So theta is equal to pi over 2 on the positive y-axis. Now, if it was 0, negative 2, then your theta would be 3 pi over 2. And the radius is, of course, just the distance from the origin, which is 2. So we know that the point 0.02 converts to a radius of 2, and your theta is pi over 2. Okay, so just in case you happen to run across a problem like that. All right, so any questions? All right, so I'll go ahead and stop there so you can get to your car before the sky opens up. Okay, so next class, we will actually start 11:04 and we will be done with all the lectures. And the only reason we have so much time left is because the exams are online. So all the days that we would have been in class taking the exam, kind of took them online and we lectured through those days. So we're a nice little bit ahead of schedule. So after tomorrow, I'll still be here. So if you want to come in and ask questions, you're more than welcome to. But I will send out an announcement giving like the day and time and all. Well, you already know the day. It's the last day of class. But the time and room number and everything for the final. So this way you'll have that. All right. So everybody, see you tomorrow and stay dry.
I have a question.
Sure.
So the final, you said we use a graphing calculator?
Yes.
Okay.
Yeah.
And then after tomorrow,
Mhm.
we're not gonna have like you're gonna be here just for like questions, right?
Yep,
You're not
just
gonna
for
like
questions.
do any demonstrations or nothing.
Nope, there's not going to be any like
Okay.
new material covered or
Yeah,
anything.
so it's not like practice or anything like that.
Oh, no.
Just just
Not at all. Yeah,
Okay.
just here if you have questions.
Okay. All right. Thank you.
You're welcome.
So
Hi.
last week,
Mhm.
my family, we adopted a new puppy, and I've been very busy hoping to take care of that, and so I've fallen behind on some of my work.
Mhm.
And so I was wondering if I could just have like an extra, like until the end of the week or something to catch up on the work, because
Actually, I was going to reopen all of the assignments and extend the due date. So, like towards the end of the semester, I always do that just to give people who may have missed some a chance to get all the points they can. So yeah, I was just going to reopen all of them anyway. So
all right, thank you.
all right, you're welcome.
Have a good day.
You too. Good luck with your puppy.
You want to see a photo?
Yeah. Oh man, you asked the wrong person if you want to see a photo of a puppy. Puppies are my weakness.
Oh, so we already have a dog. I'll show you something funny. So the new puppy took over. Her new puppy, she took over his new crate, or not his new crate, but his crate, and then he's over here sleeping on her little bed.
As you can see, my cover photo is my little chihuahua. So trust me, I know you'll snap a million pictures.
Yeah. All right. Have a good day.
You too. The exam. Which exam? With those, you saying you can't access the reviews? Oh, yep. All the reviews are prepped for the final. Yep. So let me take a quick look. And here we go. Yep. So all of those let me see if I can share the screen. Give me 1 second. And I'm going to turn this share off and see if I can turn on the screen. There we go. Yep, so this one right here, that final exam module, all of those are reviews for the final. Oh, and actually, let me open that up. Because to kind of motivate people, so for each final exam review, you get 70% on each one. You get an extra 1% added to your overall grade. So if you have a 75, if you do each one over 70%, you can get an additional 6 points. So that 75 could turn into an 81. Yep, so that's each individual chapter. Yep, doing the review will help very much. Yep, we're doing them in the computer lab. I was unable to send out the email like I wanted to last week, but only because I lost power on Thursday night / Friday morning, and I didn't get it back till like Sunday morning. So I didn't have time to kind of do it then, but I'm gonna send out the email actually right now. So kind of telling everyone the room number and everything. So it'll all be just like the exams on Newton. The only difference is you'll be in class. So that's the only difference. I don't think the formulas are uploaded to Canvas. I think you might have to write those on a sheet of paper yourself. And you will be allowed to have one 8.5 by 11 sheet of paper, like anything you want on the front and back to bring with you. You're welcome. You have a good evening, even though the weather is horrible. I said evening because it's so great out there. I keep forgetting it's a lot earlier than that. Okay, well, have a safe drive to work.